calculating the electrical load. So this particular video will focus on electrical load. Last two videos we have focused on area and the water load calculation. This particular video we will talk about the electrical load required. My thanks to Mr. Chatwal for the book which has been such a guide and a textbook for making these videos. Now, looking at electrical load, what is electricity? It is something without which none of modern life exists actually. I mean, people cannot even imagine life without electricity. So wherever it is used, it's used for lighting, for air cooling, air conditioning, pumping of water, heating, using your computer, cooking machineries, and your ventilation system, your alarm system, lifts, elevators, recreation, refrigeration, decoration, alarm system, all of it uses electricity, right? So if it uses electricity without which life is not possible, as we know it, we require to be able to calculate the load requirement, right? So there are two kind of loads which are there. One is the connected load and two is the actual load. What's the connected load? Connected load is the sum of the total load of equipment which are connected at any given point. And the actual load is a subset of it. It is that part of it, that part of the connected load which is being used. Now, for example, at night you might have less of load because the air conditioning of the restaurant cannot be on if it's a specialty restaurant. I'm talking about midnight. Let's say 1 o'clock to morning 10 o'clock or 12 o'clock the staff come in. Till then the restaurants do not require to have air conditioning, nor do they require to have lighting. All of that comes in after the staff comes in and the work starts over at the restaurant. So that is a part of the actual load. So the actual load at night we expect it to be lesser, and during daytime and peak timings we expect it to be more. Similarly, in rooms the equation might be a little different. If the guests are visitors, then you might have more. If guests are tourists, then in the morning the load will be lesser because they are out possibly on visiting and sightseeing. Whereas at night the load in the room will be higher because the air conditioning is on and so on. Yeah. So the whole thing about lighting. Now the first thing now we talk about is lighting. So in a room, we are looking at a room over here. So in a room you have different kind of gadgets that take up the lighting. Now it's not necessary that all of these are used all the time. The room lighting is, you have taken over here 2 into 60 watts of lamp. Now these need not be 60 watts because the modern LED lamps which are there might be lesser than that. It could be even your 10-watt lamps, because at the end of it the whole thing is to do with the luminosity, which is lumens, L-U-M-E-N. So the modern LED bulbs, 10 watts, 15 watts LED bulb gives the equivalent of 60 watts of what the early lamps used to give. The cost for the bulb might be more, but the life is also good, and the power consumption, you see, instead of 60 watts, if you had only, let's say, 10 or 15 watts, then you're looking at making the power consumption to 1/4 over there. For the same illumination, you're using less wattage over there. The load reduces. And you have considered lamps, toilet lamps, ceiling fan. Electric iron is given over here as 1200 watts. Hair dryer 650 watt, TV 80 watts. Now here, this is a very nice example to look at all of this. Sum of all of this is roughly equal to about 3 kilowatts. 2960 is what the calculation. 2960 is what the calculation is. It is the sum of all of these together, right? But now, how long do you think a guest is going to use the iron? 1200 watts. So I don't think it is. It's only more of a part of the connected load. But sorry, it's more of the part, yeah, it's part of the connected load, but it's not a part of the load in use. Similarly, the hair dryer also is used only, very, uh, not too often. But yes, your mini refrigerator is on most of the time. So this is a part of the load which is uh, utilized throughout the day. Anyway, uh, to make a long and short of it, we are looking at 3 watts of connected load per room. Restaurants similarly make calculation of lighting about 200 watts, 20 numbers, 50 watt lamp, 1200 decorative, you have 20 to 15 watts, 300 toilet lamp, ceiling fan, exhaust fan, TV, computer, refrigerator, coffee machine. Yeah, they missed out on the air conditioning, but anyways, the idea we get the idea of what this is about. So, air conditioning or the heating system, depending on which part of the world you are. So, totally, you have roughly about a 12 kilowatt connection. So, 12 to 13 kilowatt connection is what you're looking at for a given restaurant, right? It's a sum of all of these different things: coffee machine, refrigerator, computers, and yeah, lighting fan and so on, everything together makes it 13 kilowatts. Similarly, kitchen you have got lighting, toilet lamp, exhaust system. So you see the exhaust system, they've given pretty heavy duty load over here. Yeah, in fact, the kind of load for your exhaust system is measured in something called HP, which is a horsepower, which is roughly 1 horsepower is roughly about 750 watts if I recollect it right. Yeah, so this is about roughly 10 horsepower of exhaust system that they have considered over here. And then you have your maybe the printer that you require, refrigeration, dishwashing machine, baking oven, other machines, all of this together, you have a requirement of about 25 kilowatts, right? So 22,500 is what it comes to. You're rounding it off to 25 kilowatts. Laundry has got a lot of machines over there, you see. So all these are pretty much power guzzlers. You have scrubbing machines, vacuum cleaner, ironing, linen washing machines, computer printers are a small part. Exhaust system is there because there's heat generated and there's steam generated, so you have to have an exhaust system over here, and toilet lamps and lighting. So as you can see, the lighting is not much. It is the machines which are taking up the exhaust system, the washing machine, ironing machine. All of these are taking up the load requirement, and totally you get about 31.15 or roughly about 32 kilowatts is the connected load for a laundry. Usually some spare amount is also added to it in case there is additional machinery requirement, etc., or upgradation of machinery required at some point. So even spare load connection is also given at points. Front office and your lobby. So over here you can see the big time. You have the lifts which take up big time power. So you have 10,000 watts or 10 kilowatts per lift. Yeah, so that's big time over here. Coffee shop. Uh, Now I guess we are not talking about a coffee shop here. You might be talking about coffee dispensing machine perhaps, or some of that together taken at 5,000 watts, and chandeliers are there. Lighting is not too much. Yeah. So all of it together comes to again about another 32 kilowatts is what it comes to your front office. Maintenance and services. Here you have got huge. You have AC compressors. This is the biggest one. So this is how many? This is 300 kilowatts by itself. Your AC compressors, and you have blowers. Blowers are basically for your cooling systems and your exhaust systems. So you have blowers. You have 150 kilowatts over here. Right? Lighting is relatively not too much for maintenance services. It's supposed to be well lit, so you have 1200 watts over there, and then your toilet lamps a little bit over there. Water pumps take up good amount, so you have 50 kilowatts set up out for water pumps, and building general lighting is about 10 kilowatts. Yeah. So all in all, you have about 520 kilowatts all in all requirement from the maintenance and service perspective. So we now try to estimate how do we do. We have already calculated that for accommodation of rooms we require 600 kilowatts, restaurant 26 kilowatts, similarly, maintenance 520 kilowatts. So overall we see that the total connected load is 1260 kilowatts, right? So kVA stands for your kilovolt ampere of a transformer. It is equal to kilowatts divided by something called power factor. What is power factor? Power factor, it is defined as the ratio of real power absorbed by the load to the apparent power flowing in the circuit, right? So it would simply mean possibly in one sense it is efficiency of the power used is how would I look at it, because you are looking at the ratio of the real power absorbed divided by the apparent power flowing in the circuit. So which we have considered over here as 90%, right? Which we have taken it as 0.9. So you have 1260, which is your connected load divided by 0.9, so it comes to 1400 kilovolt ampere. So the transformers that we have are not available in custom made sizes. The nearest size available to this is 1500 kVA. So probably that is the transformer that we should be going for. Right. Now if you're looking at the transformer that we asked for, it's about 1500 kVA. The kind of energy consumption, if you have to look at now, like we figured out 1200 connected load, right? You have 1260 kilowatts of load connected at any point in time, and you have considered something called a load factor. Now, what is load factor? Load factor is the average load divided by the peak load in a specified time period. Which means, let's say, if if let's say the peak load is, let's say, 1200 or 1260, everything is on at 1260, but average load throughout the whole day, it is if you look at the kind of load which is used through the whole day, you might be utilizing only 40% of it on an average. So that is the load factor. So you look at load factor as 0.4. And there's something called the utility factor. Utility factor again means that, all right, you have connected a machine which is being used, but what is the ratio of the time that the machine is used to the total time that it could be in use? Like we talked about the iron. So for an iron, the utility factor is pretty low. For a hair dryer, the utility factor is pretty low. But for a minibar, the utility factor is pretty high. For a refrigerator, the utility factor, refrigerator in the kitchen, the utility factor is pretty high, right? So because the refrigerator is on 24 hours a day, so utility factor would be 1 over there. Right? So, but on an average, we find that the utility factor we have taken to be, let's say, about 0.5. Right? Load factor is 0.4. Utilization factor, utility factor is taken at 0.5. And if you look at that, that is the kind of load per hour. So if you look at this particular aspect, 1260 into 0.4 into 0.5 is the load per hour, multiplied with 24, that is load per day, multiplied with 365, load per year. So we are looking at about 22 lakhs unit of consumption per year. So 22 lakhs when you multiply it by the rate of electricity which is charged by the government, which is different at different places, 6 rupees to 8 rupees is, I think 8 rupees is pretty common now. So anyway, whatever it is, if you multiply with 6, you get your projected electricity bill to be 1.32 crores. 1 lakh 32, sorry, 1 crore 32 lakhs, 1 crore 32 lakhs, 45,120 rupees if you multiply it by 6. So this is how we compute the machinery or the electrical load of the hotel. I would like to thank Mr. Chatwal for publishing this lovely book for facility planning. I've used it as a textbook all over in all the places.